But I'm very happy having this chance to share with you some thoughts about my book and much more importantly about ideas behind this book. So I'd like to introduce myself. Yes, I'm a professor of engineering in our School of IT and Engineering, but I'm one of very few professors who worked and lived on 3 continents, including Europe, Africa, and this continent. Taught at several universities in different cultural environments, and that gave me a kind of unique understanding of engineering education and engineering in general. Today I would like to address 3 fundamental questions. Why to care about educating creative engineers, what to do to produce or to educate some engineers, and how this could be done. And this is a subject of my book, which is available. Of course, if anybody is interested in buying it, we have special sale. I think it is on sale today, so we would buy for cash or checks. And let me start working on the first question, why? Why, up to a certain degree, it is a result of my disappointment with the existing engineering education system. For the last several years, I was quite involved with American Society of Civil Engineers with their so-called Body of Knowledge Committee. This Body of Knowledge Committee is supposed to determine what should be taught to future civil engineers and to determine what should be expected. But I must admit that I was disappointed by progress of this committee and by their short-term thinking, more focused on details than on a big picture. And I realized that engineers today are living and learning in a kind of cursed deductive circle. We teach traditional engineering, traditional civil or mechanical engineering, and not much more. So our students follow our lead and move in this cursed circle. And of course there are reasons why engineers today aren't so successful. In the past, engineers were leaders and inventors, leaders in the society, but gradually they lost this lead, and today this lead shifted to IT people and to other professionals. Why engineers aren't successful? Well, this is a difficult question, and there are many answers. My answer is because they lost their creativity. They lost their ability to develop new ideas and to implement these ideas. We have to do something about it for a number of reasons. One, we have to, of course, establish the role of engineers as leaders within our society. But there are other equally, if not more important reasons. For example, globalization. Globalization means, in the case of engineering, outsourcing. Outsourcing is because there are now so many engineers in Eastern Europe, in China, or in India, who are well prepared to do traditional engineering, if not better prepared than engineers in this country, and who are experts moving in this, of course, cursed deductive circle. In addition, they are much less expensive than our engineers here. Here we have an interesting problem how to keep it in place. So basically, my book was written to allow our engineers to move from the circle to what I call abductive people. Engineers who are not forced to move within this circle, not follow rules and traditional engineering. And of course, this is extremely important. As a matter of fact, when I wanted to use this drawing for an ad in a magazine of American Society for Engineering Education, it was rejected as indecent because there are named people. So I hope that you accept it as it is, and of course the idea is entirely different dynamics, change in dynamics of these 2 different situations. The next question I'd like to address is what to do and how to do this. And in my case, I based my new idea for engineering education on the theory of successful intelligence. This theory was recently developed in psychology. Do we have any psychologists here? No. This is a very interesting theory which claims that to be successful in life, in professional life or in ordinary life, we have to develop so-called successful intelligence. And successful intelligence has three major components: practical intelligence, analytical intelligence, and creative intelligence. Practical intelligence deals with all simple everyday problems: how to drive a car, how to read a book. Analytical intelligence deals with solving complex analytical problems: how to design a typical bridge, or how to design, for example, a typical car. Creative intelligence is most important, and this creative intelligence is about solving problems not in traditional routine way, but problems which require new solutions. How to invent things, how to create new ideas, ideas which are different in qualitative terms from state of the art, from whatever we know. So I based my book on this concept of theory, on this theory of successful intelligence, and also on the Medici effect. If I can describe my intention, it was, I have another nice drawing. As a matter of fact, these drawings are from my book, and they were prepared by a true artist, by a true local artist working here, Mike Sykes. And basically, I wanted to use or to move engineering from a closed space to an open space, or in more traditional computational terms, from a fixed representation space to open representation space, from exploitation to exploration. Because if you want to become a leader, if you want to become an inventor, definitely you have to go outside your box. You have to start thinking outside your box. So I decided to base my book also on the principle of phenomenon which is called the Medici effect, which was discovered in political science several years ago. And basically it says that if you want to create a new quality, if you want to develop so-called emergent concept, you need a complex phenomenon called intersection. Intersection of different cultures, different kinds of knowledge, different personalities, etc. And only under these circumstances actually new things happen. The Medici effect is of course related to the Medici family, to these very rich Italian bankers who had so much money to burn that they decided to keep in their court all kinds of crazy people: artists, scientists, painters, poets, etc. And these people had a lot of time on their hands, started talking, started developing different concepts, and in the process developed entirely different understanding of their world. This new understanding led to the emergence of Renaissance, to this most creative period in our history. Our inspiration in my case came from Leonardo da Vinci. We know about him as a great painter, artist, but he was also an engineer and scholar, and our next poster, he developed 7 principles. 7 principles which are presented here. 7 principles of creative, or we could say successful people. These principles can be considered as the core of beliefs, methods, and philosophies behind his greatness, behind his genius. One was curiosity. It was about learning, about acquiring knowledge all the life. Another one is about demonstration or verification of all results through experimentation. That means building links between nature and our work. Another one is about sensitivity, understood in this case as using all senses, being open not only to traditional deductive thinking, but also to abductive creative thinking, which is usually associated with a right side of our brain. Next principle which I implemented in the context of education was sfumato, or fuzziness, seeing world as it is, not as black and white, not as a binary system, but as a very complex system in nothing is absolutely certain, everything is fuzzy, but we have of course to understand this world as it is and use it for our purposes. Next principle, particularly important from our point of view, is finding proper balance between art or liberal